Hello everyone, let's solve the problem of the day. Today we are having maximum sum increasing subsequence. Let's read the question. The problem is saying that you are given an array of n positive integers. Find the sum of the maximum subsequence of the given array such that the integers in the subsequence are sorted in a strictly increasing order. That is a strictly increasing subsequence. Alright, we are going to understand it using an example. Here we do have one example. Let's try to figure out what it is saying. So as the question stated, we have our array here. Along with the array, we have this value n, size of array, right? Now, the answer that this question should give us is actually 106, which is maximum sum of increasing subsequence. Fine. So first of all, before even talking about sum, let's figure out what is this subsequence. Okay. So if I have, let's say 1, 2, and 3 inside my array, I have to talk about subsequences. Okay, I have to talk about subsequences. So the thing is, if I am taking 1, it is a subsequence. If I am taking 1, 2, it is a subsequence. If I'm taking 1, 2, 3, it is a subsequence. And if I miss 2, that means I do not take 2 and I form 1 and 3, that is also a subsequence. Okay, people do get confused sometimes between subsequences and subarrays. So what happens, you can think of it like subarrays are actually chunks of the array. Fine. And when we talk about subsequences, every element in an array, it actually has one choice to make. Either it can join the solution or it cannot join the solution. So if I have to do it like this, we can say 1, 2, 3 are there. And first of all, they made a choice that none is going to be joining. That means we received an empty array. This is also a subsequence. Then 1 made its choice, okay, and other 2 did not come. Then only 1 is also a subsequence, right? Then if we say 1 and 2 said yes, so if 1 and 2 said yes, we can say 1 and 2 is a subsequence. Similarly, if I said 1 and 3, only these 2 said yes, 1 and 3 is also a subsequence. And again, if all wanted to join the answer, we can say 1, 2, 3. This is also a subsequence. Fine. So what happens is, at every point of time, every element has one choice to make. Either it can join the solution or it can leave it. All right. Because of this property, because of this condition, we can say we have 1, 2, and 3. It has 2 choices, it has 2 choices, it has 2 choices. So it is 2 to the power 3, right? At every point we have 2 choices. So in total, how many combinations we are going to be getting, how many answers we can get is actually 2 to the power 3. All right. So this is how we figure out how many total subsequences can be formed. Now we are clear about what are subsequences. Now we are talking about increasing subsequence. Okay, let's take another example for it. Okay, I have taken one random array here, and if I have to form subsequences, can I say 1 and 7? Is this an increasing subsequence? Yes, this is, because you can see 1 is smaller than 7 and this is a sort of sorted array, correct? Now if I take 1, 7, 2, is this a strictly increasing subsequence? Well, it is not, because you can see that 7 and 2 are not in sorted order. That means this is a subsequence, but we cannot take that inside this answer that we have to form, right? That means this is discarded. Let's talk about 1 and 2 only. 1 and 2, are these increasing subsequence? Yes, these are increasing subsequence. Also, now let's say 1, 2, 12, 1, 2, and 12. This is also an increasing subsequence because it is not hindering the property of being sorted. After that, if I have to take 1, 4, and 5, 1, 4, 5 also sorted, 1, 2, 4, 5 also sorted, 1, 2, 12, 5 not sorted. That means not a solution, not a subsequence that we have to consider. So now I hope you are very clear about what is increasing subsequence, right? Now what is the question saying? The question is saying that we have to find out these increasing subsequences and we have to return the maximum sum. That means all the subsequences that we have to calculate the sum of it, and whatsoever sum is the maximum, we have to return that. According to this example, if we do subsequencing, increasing subsequences here in this array, and we find out the maximum sum, it is going to be 106. So let's solve and see if that is correct. Okay, so here is the array. We can think of making the subsequences recursively. We can say that here is one. Whatsoever the list of subsequence that this subarray forms, I will take that. I will see all the possibilities that I can make with 1, with the availability of 1, and with the unavailability of 1. Okay, I'll combine all the sequences and will give the final answer. This is the logic. Let's see how it works. We are going to do it for 1. 1 will be calling, then after this call, when this array is taken, 101 will be calling to this particular part of the array, right? Then similarly, 2 will be making the call, 3 will be making the call, and we'll be ending up here at 100. Fine. After 100, you can say there is the array is over, and the base case is that we are taking empty as one of the subsequence. So I said I've taken empty as one of the subsequence. Fine. Now I come to 100. 100 has two choices to make. Either it can include itself, or it does not include itself, right? So once we are at 10, once we are at 100, firstly it is not including itself, and then it is including itself, right? Now let me come to 3. What will happen in 3? 3 will be getting this as the answer array, this as the vector of vectors, you can say, right? Now for 3, these subsequences are already valid. These subsequences are already valid. And 3 has to make the choice that if it combines with these two, what are the new subsequences it will be forming. So 3 when combined with nothing will end up 3. 3 when combined with 100, it will be 3, 100. Okay, so now we have 4 subsequences. Remember one thing, that when you were taking this chunk, your array was of size 1, right? And when you are taking this chunk, your array is of size 2. So what is happening? For 1, it is 2 to the power 1. For 2, it is 2 to the power 2. But this is, we are considering all the subsequences. We do have to discard some. Don't forget that. Let's talk about 2. So for 2, it already has all the subsequences that are formed so far. That means if I have to write, I can say we have empty, we have 100, we have 3, 100. Now we have to make the choice with 2. 2 will be combining with them all, and 2 will not be combining with them all. So it will be 2 with empty, 2. 2 with 100 will be 2, 100. 2 with 3 would be 2, 3. 2 with 3, 100 will be 2, 3, 100. Fine. Okay, notice one thing more. All the subsequences that we have been forming so far are actually increasing in order. That means these are strictly increasing subsequences. We have not messed up the sequence yet. All right, now coming to this point, and here we will be actually sacrificing the sequence that we have been making so far. We need to now discard some of the subsequences. Let's take these ones. So all the ones formed so far will be considered. Now let's talk about 101. 101 combined with empty will be 101, which in itself is an increasing subsequence. If you have only one value, obviously it is an increasing subsequence, right? Now let's combine 101 with 100. Is it possible? If we say 101, 100, is it a strictly increasing subsequence? It is not, right? It is not in the sorted manner. That's why we are not going to consider this subsequence. Again, 101 with 3, not considered. 101 with 3, 100, no chance, not considered, not considered, not considered, not considered. Only individually it will be considered. Fine. Now let's do the same thing with 1. Do the same thing with 1. We have all the subsequences, correct? And this 1012. Now we have to make choices with 1. 1 with empty is going to be 1. 1 with 100 will be 1, 100. Similarly, 1 with 3 let me write it here, 1 comma 3, 1 comma 3 comma 100, 1 comma 2, 1 comma 2 comma 100, 2 comma 3, 1 comma 2 comma 3, then 1 comma 2 comma 3 comma 100, and 101, 1 and 1 comma 100. Fine. So these are all the subsequences. Now what do we want to do? We want to find the maximum sum. So if we start to sum it all up, what will be having? Empty, that means let me write the sums here. Okay, now start calculating. For nothing, it's 0. Then we have 100, then we have 3, then we have 100 plus 3, 103. Then 2 alone, 102, 2 and 3, it will be 5. It will be 105, 101, 1, 101, adding these two. Then we have 1 comma 3, it will be 4, 104, it will be 3. Then we have 103. Then we have 1 comma 2 comma 3. That means we have 6. Then we have 106. And these one are actually already taken here. So this is your whole sums of all the subsequence which are strictly increasing. What do we have to pick and what do we have to return as the answer? We have to return the maximum one. What is the maximum one? The maximum one is 106. It is 106. Correct? So this is how now you know how you're getting 106 as the answer. Fine. But this approach is actually really, you can say, big and complex, correct? And do take a lot of complexity. How we can think of it in a better way? We have broken down the problem till the end and we started building up the solution from there. So let's try thinking about the same in a little different manner. What if we store the answers from the beginning till the end? Okay. Now that we have our array, so the values that we have are 1, 101, 2, 3, and 100. Fine. So we know this. Now let's try to form a solution. Now let's try to form a solution in a way that we are building up the answer from the scratch. Okay. So if we just talk about 1, we are here and we are just talking about 1. If we only have 1, what are the subsequence? The subsequences, the only subsequence is 1, correct? Which is increasing in order, and the sum of it is also 1, correct? Now let's see about 101. If we include 1 with 101, what are the subsequences possible? Well, 101 is possible, right? And if we take that, if we take 1,101, what will be the sum of it? The sum will be 102, correct? And now that we have 2, correct? Now that we have 2, what is the number we can pair it with? Well, till now it is only one number, which is 1, right? So we can say that 1 is already having the sum to be 1. The element 1 is already having the sum to be 1. What will we do? What will we do? We have 1 here. Now we add 2 to it. 1, 2, strictly increasing subsequence, correct? That means it can be considered. Now what is the sum? Already existing is 1. We add 2 to it, it will become 3. Fine. Now let's come to this 3. Now let's come to this 3. Now can you tell me what are the subsequence, or you can say the elements we can take to make the subsequence? Well, now things get interesting. Things get really interesting. We have 2 and we have 1. We have 2 choices, right? We can have 2 as a subsequence. We can form 2, 3, or we can form 1, 3, right? But if you actually see, what value are we storing here? We are storing the maximum sum which is formed till now. If we were considering the array till 2 and we were including 2 in our subsequence, what was the maximum sum calculated till here? That means If we talk about this 3 is formed when 1 and 2 are already taken. When the subsequence, one of the valid increasing subsequences has been taken, that is why this 3 has formed. 3 has been formed. Now what do we have to do? The work is easier now. We already have the data of this 3. We are having this element 3 now. It is possible to make subsequences with 1 and 2, correct? But what value should we go with? We have to go with the maximum one. We have already calculated the sum so far. So all the subsequences that are made by 2, all the previous ones are included in it. And the maximum is stored here. So when we talk about 3, we already have 1 and 2 there, correct? If we are taking this 2 and the sum is 3, correct? The sum is 3. So what we will do, we'll add 3 plus 3, it will be 6, right? Now we are here at 100. What are the values that can be included? 3 can be included. We can make 3, 100. 2 can be included. 1 can be included. 101 cannot be included. Why? Because it is bigger than the value that we are having here. Fine. Now what do we have to do? We have to again see what are the valid values, and from the valid values, what actually is holding the maximum sum. Till here, the maximum sum is 6. So what we can do is we can simply add this here, correct? Because this 6 is formed by 1, 2 and 3, and when we add up 100 in it, it will become 106. So we were able to do the same work in a way easier manner, right? And we are actually tabulating it. And you can name this array as DB or cache, whatsoever you want, but this is how we are approaching it in a better way. I hope you have understood what we are actually doing. Let's discuss the algorithm for it. It will be even more clear to you. So here is the algorithm. Let's read it to have a clearer understanding. So what does it say? It says us to create a DP array of length n and initialize it with 0, right? So we have 5 elements in the example that we are taking. Let's deal with it. So I will take one array and I will have 5 partitions. And all the values are filled with 0, right? Now, as you can see, what we are doing, we are running a loop from 0 to n minus 1, and we are taking I. So what we will do, actually that we are running this loop onto the values. That means onto the values of the array that we are given. So let me make that too, just corresponding to it. Right, corresponding to it, what are the values? The values that we have are 1, 101, 2, 3 and 100, correct? These are the values. So my I would be moving from here till the end, correct? After this, I have to make a S max, or you can say a small max. This is to keep a track of maximum to fill the nth value that we are at. So what do I mean by that? Let's take an example that we have traveled so far and we have made our DP. We were building our answers, we were able to build this position, we were able to build this position. Now we have to fill up this position. We have to change this 0 to something. What will I do? My I is here, right? I have to take one more variable j, which is for this loop. It will be traveling from 0 till here, till where my I is. And what it needs to figure out? It needs to first of all figure out what are the values that we can take under consideration. We can only consider those values which are less than our current value. Why? Because we are talking about increasing subsequences, right? Okay, now we have considered, assume 3 values. Okay, I'm not talking about this, just in general. We have 3 points in our array which can be considered. So let's say any random example, I have 50 to be this number, and I can consider 33, and I have 20 here, I have 10 here. I can make subsequences with all the choices. But let's say 33 was giving me a value, a total complete value of 105, which was greater than these values. Let me take up 10 here and 30 here. And there could be some values in between. I'm just taking up random numbers. Okay. So just to let you know that if this is the biggest value, we need to put this here. We need to put this here and then we will add 50 to it. Fine. This is what we have to do. For this, I've taken this J loop, right? It will be going from 0 till where my I is. Every time I'm going to be comparing my jth with my ith value. Okay, if we are here, my jth will be comparing with I, with that means my 1 will be compared with 2. Yes, it is less, so we can get inside this if. Here we are checking that if my dpj is greater than s max. So building our s max now, if we are here at 1 and we have compared this 1 less than 2, that means it's true, right? Then we are going to be getting inside this if. We'll check if dpj is greater than s max. Initially our s max is 0 and dpj holds some value. If we talk about this example and our j is here, dpj is holding 10, correct? So for the time being, what will my s max be? Till now my small max can be considered as 10, right? Because 0 is less than 10 and this condition passed and I have initialized it now with 10. When my j increases, now the situation is I am again going to compare if my j is greater than my ith, actually less than my ith, sorry, less than my ith, then what will I do? 20 is less than 50 as per this example, that means it's true. What will I do now? I will update the s max if it is bigger. 30 is bigger than 10. Now this will be updated as 30, correct? Similar goes for 33. Is 33 smaller than 50? It is. Is the sum at 33 at the position of 33, the dp is containing, is that greater than the previous one? It is greater than the previous one. So we are going to update that, right? Eventually, after this jth loop is ended, once this jth loop is ended, we simply have to mark the value that we have found so far, which is a smaller max. We have to add it with ARRI, that means the position we want to fill. That means S max is 105, we add 50 with it and then we get 155, right? And we put that 155 at the ith dp, okay? And after that we return whatsoever is the maximum in dp. I'll tell you this later. First, let's create the dp and see how it is working. So let's create the dp again. We have this and initially every value is 0, correct? What I'll do initially is I will be having j from 0 to I, that means this would not work. What I'll do is I will say dpi equals s max plus ARRI. S max is 0 because this loop has not run yet. That means my dpi will be my ARRI. My 0 will be updated with 1. Okay. Now after that, once 0 is done, we move to 1. I'm talking about the ith positions. Yeah. Once we do that, we can see that we are here to fill this point, to fill the 1 index of our dp. So to calculate it, we have to run our j loop from the beginning till here, which is only 1 index. Now we'll check. We'll again have another s max, which will be 0. We'll check that if ARRJ is less than ARRI. ARRI is 100, ARRJ is 1. Is this less than that? Correct. What do we have to do? Is my dpj greater than s max? S max is 0 right now. What is my dpj? Dpj is 1. S max will be 1. S max will now be 1. Now what do I have to do? Well, my j loop ends here. And what am I doing here? dpi equals s max plus ARRI. dpi equals s max 1 plus 101. It will become 102. Fine. Now I will move again. Now we're talking about 2. This index. The I will be moving, the j will be moving till I. That means we have to again begin from here and go till here. What will happen now? We have to check if ARRJ is less than ARRI. ARRJ is 1, is less than 2. True. Do we have to update this small s max, small max? Yes. So from 0 it will now become 1. We will travel to this one, 101. Is it less than 2? False. That means we don't have to do anything. Again, we'll end up here. dpi equals s max plus ARRI. S max is 1 and ARRI is 2, which means 1 plus 2, it will end up 3. Fine. Let's do it 2 more times. We are now talking about the third index here. So what do we have to do? We have to fill up this place. I will travel till one more step. That means beginning from here till here. 1, will it be considered? Yes, right? So right now my S max was again 0. It got updated to 1. Taking 101 won't be considered. 2, that will be considered. It is having the value 3. 3 greater than 1, yes, S max updated to 3. Now we have this element, that means the J loop is ended. We again have to execute this dpi equals S max plus ARRI. So dpi will be S max, which is 3 plus 3, this 3, correct? It will be 6. All right. Now we have one more step for I. I will go to 4, correct? That means this last index, and now we are talking about this cell. We have to fill this cell. What will we do? We will check, can we consider 1? We can consider 1 because it is less than 100. And then can we consider 101? We cannot consider 101 because 100 is smaller than that. We are talking about increasing subsequences. 1 can be considered, 2 can be considered, 3 can be considered. Which is the greatest of them all? 3, because it is having the sum to be 6. What do we have to do? We have to do 100 plus 6. It will become 106. Correct? After that, how our DPRA looks like? The DPRA looks like 1, 102, 3 and 6, and then we have 106. What do we have to return as the answer? We have to return the maximum value that we have in our DPRA. Here we have 106. 106 is going to be our final answer, right? Let's see the code for the same. Well, here it is a function that we will receive and the logic that I have coded. Simply, I have made my DP. I have run the ith loop that we have seen the working for. I'm initializing my S max with 0 just before this J loop. And inside the J loop, I'm comparing ARRJ and ARRI to find out what are the possible picks that we can take for making a subsequence, for assuming a subsequence, and then we are checking the DP values. If we get a bigger one, I will update my S max. Once my J is done, that means my S max will be having the maximum value so far. It will be added to the current value and that will be stored in the DP at the ith position. Eventually, once the DP array is completely made, I will return the maximum of the DP, right? So let's try to run this code. So here's the code. Let's try compiling it. So yes, it is giving us the expected output. Let's try to submit that and check it against all the test cases. Okay. So it has passed all the test cases successfully. If we have to talk about the complexity of it a little, well, we have two loops, nested loops, I and j, and it precisely going to be n plus 1 by 2, or we can say broadly that it is going to be on square. And the space complexity is only the DP array that we are taking as extra space. So the space complexity is on. So I hope you have understood the problem. Do comment if you like the approach and the solution, and keep coding. Thank you.